Okay, let's start off with another type of tutorial. Let's look at some traditional ciphers in cryptography. One of the very important cipher and first ever historical mathematical cipher that exists is actually known as Caesar cipher. And I'm a believer that everyone should know this. Even the kids should know this. It's a very interesting cipher. Historically speaking, this is the cipher which is used by Julius Caesar. It was additive in nature and it was monoalphabetic. So I'll define this. What do I mean by monoalphabetic cipher? So the simple definition of this cipher was, Caesar cipher was, that if you have C is equals to your message plus some key mod 26. Okay, so let's look at it. If I want to get a ciphertext, what should I do? I'll take my message, I'll add a key to it, and I'll take mod with 26, and you will get a ciphertext. So it's a stream cipher. It's not a block cipher. It's actually additive in nature. Plus, it's a shift cipher. It actually shifts the letter, and it's monoalphabetic. We will see what do I mean by monoalphabetic. Monoalphabetic means that one letter will be mapped to only one letter. So for example, if I have a ciphertext, let's say hello, in which I have I have HELLO. So L is going to map to a same ciphertext. So it's been monoalphabetic cipher. In order for me to decrypt my message, so message is going to be C minus K mod 26. So I'll take my message. So it's a stream-based cipher. So it's additive, it's shift in nature, monoalphabetic, and it's a stream-based cipher. What do I mean by stream-based cipher? That one alphabet at a time. So it will encrypt one alphabet, then you will put another alphabet, then another alphabet, then another alphabet, and so on. Okay, so in order for me to get a message, you will take that particular alphabet, subtract key from it, and take a mod with 26. So if you want to see how does the modular arithmetic goes, you can refer to my tutorials which were done earlier in this series of cryptography. Okay, so let's make a small code book in order for me to solve this. So let's make a small code book. And let's make this code book as being this. So 26 is in English. In English, there are 26 alphabets. That's why I'm using 26 as being a modulus. So let's say I have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Let's assign the alphabet. So these are the alphabet in English book, and let's assign some value to it. So starting from 0, let's assign 0 for A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So let's make a small code book. In this code book, I have alphabets from A to Z and assign them some value. So A is 0 and so on, all the way up to 25. So there are 26 alphabets in English language. So let's do encryption. How would I perform encryption? And then we will do decryption as well. So let's say I have a message. So here's my example. Let's say I have a message. Our message reads, let's do a small message. Hello. All right. So we want to encrypt this message. So the definition of ciphertext is C is equals to message plus key mod 26. All right. So in actual Caesar cipher, key is your key. It was 3, but you can choose any key you want. So for example, if you're trying to send an encrypted message using Caesar cipher to, let's say, your friend, you can choose a key. But in actual Caesar cipher, the key was actually 3. So it was actually shifting the letters 3 places to your right cyclically. So in this example, we'll take key as to be 3. You can take any key you want. Okay. So let's look at our code. But let's try to encrypt hello. So H has a code value of what? 7. As you can see from here, H has a value of 7. So we're encrypting. So let's do CH just to see. Okay, CH. H has a value of 7. My key is 3. So mod 26. All right. So this value turns out to be what? 7 plus 3 is 10, mod 26. If my modulus is bigger and the number that I'm taking a mod of is smaller, I'll get the same letter. I'll get the same number. So this is 10. All right. So I'm going to do the same for E, CE. C for ciphertext, we're encrypting H. That's why I'm putting a subscript of H. Here I'm putting a subscript of E. So in this way, we are consistent. So here it's going to be what? You have, what is the value of E? E has a value of 4. So 4 plus 3 mod 26. So this is 7 mod 26. 4 plus 3 is 7 mod 26. Because my modulus is bigger and the number is smaller, I'll get the same thing. And let's do L. I got 2 of them, so we'll just do one and then we'll do the same for the other one. The value of L turns out to be 11. So 11 plus 3 mod 26. So 11 plus 3 is 14. 14 mod 26. I'll get 14. I got 2 of them, and it's a monoalphabetic cipher, so I'll get the same thing for L again. And let's do O. CO. O is representing the message letter that we're encrypting, while C is saying we're actually making a ciphertext. So CO is going to be, O has a value of what? 14. So 14 plus 3 mod 26. So that turns out to be 17. So let's map these values to your code book. So H will turn out to be 10. 10 has a value of K. All right. Then we have E. E is encrypted to be 7. So 7 is H. All right. L is 14. So N encryption, the encryption of L turns out to be 14. So 14 is O. And there are 2 of them. So I'm going to have, for one O, I'll have O, and then for another L, I'll have O. And then O turns out to be 17, which is R. So my encryption for hello is going to be KHOOR. So this is my encrypted message. So when I look at my code book, I can also do that. So I have H. Let's shift my letters to 2 places, 3 places. So it's going to be 1, 2, 3. So it's K. Let's say I have E. Let's shift this to 3 places. 1, 2, 3. I have H. And then this way you encrypt them. The way we're going to decrypt this is quite simple now. So decryption process is like this. This decryption, we're going to do opposite of that. And the opposite of, as we know, for additive inverse. So we're going to do additive inverse, which is actually minus. But multiplicative inverse, we don't have divide in modular arithmetic. We do have divide, but we actually look for a multiplicative inverse of that. You can also look at the video of mine on this. So this message, so now your message, I want to decrypt this. So this is going to be C minus K mod 26. This is the definition. All right. So if I want to get my message back, what do I need to do? I want to get what is K stands for. So my ciphertext was K. The value of K was 10. So 10 minus 3 mod 26. So that turns out to be what? 10 minus 3 is 7. 7 mod 26. I'll get 7 back. So this is H. Alright. Then the next letter is H. So we're trying to find out what does H, which was an encrypted letter, what does it represent? So MH is going to be, the value of H was 7. 7 minus 3, K is being shared between the sender and the receiver. 7 minus 3 is 4, mod 26. So this is 10 minus 3 is 7. 7 minus 3 is minus 26. 7 minus 3 is 4. So this 4 would represent what letter? Would represent E. I'll do the same for O. So MO, what is the value of O? Is 14. 14 minus 3, which is actually your key, dash mod 26. So 14 minus 3 is actually 11. So this is 11, and 11 would corresponds to L, and there are two of them. So I don't need to repeat the same thing. And MR is going to be, R has a value of 17 here. So 17 minus 3 mod 26. 17 minus 3 is 14, mod 26, it'll get 14, and this thing has a value of 14 as a value of O. So your encrypted, once your encrypted message, after decrypting it, it would become HLLO. Okay, so let's look at a couple of things regarding this particular cipher. This is a cipher I think everyone should know, even your kids supposed to know this. You can decide the key beforehand. Okay, it's additive in nature, so we can see additive, and the opposite of additive inverse, which is minus with negative sign. It is actually a shift based cipher, which is actually shifting the letters with respect to what is the key. It's MonoAlphabetic, which means that every time it will map the same. What it means is this: if I have L that occurs multiple times in my text, it will map to a same letter, which makes it susceptible to frequency analysis attack. This is in terms of a stream cipher, which means I'm doing one letter at a time and then encrypting it. So I hope you like this small tutorial on Caesar cipher. If you have any questions, please let me know in the comment section, and don't forget to subscribe to my channel.